Hello, welcome everybody to channel Sube. Today I am going to discuss question number 40 of 2020 Physics MCQ paper. An infinitely long thin straight wire which is located on the z-axis has a linear charge density of minus lambda. A small positive charge plus q or mass m is allowed to move in the xy plane in a circular path of radius r about the wire. The periodic time of the charge is given by, there are 5 answers. Capital T is what they want us to find out. So let us see how this can be done. So let us draw a little sketch. The wire is located like this along the z-axis, infinite, therefore we have to show dash lines. Then it has, let's fill inside to show that it is a wire. So this wire is charged minus lambda. That means there are charged particles on the surface of this wire. We can show like this, minus like that, both side. Actually not both side, around the wire, but on the surface, there are no charges inside a metal conductor. So charges are distributed like that along the surface. So what is this lambda? What is charge density? Charge density is the total charge distributed along 1 meter of the wire. So if this length is 1 meter, q is then lambda. That is what charge density, charge per meter. So now we know q, we know the length of the wire. We consider only this limit. The wire extends to infinity. This side also extend to infinity. So now we can draw the particle. The question, they say that a particle having positive plus q charge rotates around this wire. So I draw it like this, the particle whose charge is plus q, this one. I take my time. You don't have to do all these things in the exam. You can just start from the equation. To understand, I do these things clearly, taking time, because this is not exam, this is a sort of lesson. So it has a velocity, otherwise it can't move. Say the velocity is, the direction of velocity is this way, like that it moves. The mass is m, radius r. Here everything is given in symbol. Then to find out capital T of this particle, we have to go to mechanics, especially because the time is determined by the velocity and the length of the path. The path is this red line, so we have to go to mechanics. If a particle or if any object moves along a circular path, we know that centripetal force must be there, that equals mv squared divided by r. F equals mv squared divided by r. So that is the force that is necessary to move along this circular path. This amount of force is needed. So who supplies it? The direction of electrostatic force is towards the wire, this way. So that we can find by the equation F equals EQ. So E is the field strength of this point, of this place. Now we have to find out, before that I have to say, so these two equations must be equal to each other, because this amount of force is given by this electrostatic force, because even though we have an equation like this, there is no real such a force, that is only the value. So the real force is this one, this electrostatic force. So it supplies the amount needed by this equation 1. So we can equate equation 1 equals equation 2, then mv squared divided by r equals E Q. Then we have to get the relationship, but we have to find out period. So capital T is what we have to find. So capital T is not here in this equation, so we can't find, but we can get a relationship with this velocity. So we know the velocity can be written by s over t, then the distance divided by the time. So velocity equals, the distance is, if we consider this circle, one circle, the distance is 2 pi r. Then the time for one circle is capital T. So now we have the relationship. So we can apply it to substitute it here. m v squared. V squared is 2 phi r divided by t, total thing squared. So here r equals e q. So t is here now. Then simplify 4 phi squared r squared t squared eq. Then 1 r cancel. 4 phi squared r m 4 phi squared r m divided by t squared equals eq. Then we need t. To find out t, we take this t to this side. Then t squared equals 4 phi squared r m divided by eq. So t is the root of whole thing, 4 phi squared. We can take 4 phi squared out of the root, then 2 phi r m over eq. So this is the equation. So far we can simplify. So we have to find out e. To find out e, we should go to Gauss theory. But in this real-time examination, you should remember that equation E equals lambda divided by 2 phi epsilon naught r. This equation you should remember, you should keep it in mind. So let us apply. I will show you how we get it. It is out of the scope here, but I will show you. So we can apply it here. Then t equals 2 phi whole thing squared root r m q, then e divided by e, then this whole thing turn upside down and multiply, then 2 phi epsilon naught r divided by lambda. This is the value for t. Root 4 phi squared, here phi squared and here phi, then phi cube, 4 multiplied by 2, we get 8 r squared, there is no another r here, then r squared, then this thing okay, this thing okay, this thing okay, then epsilon naught m divided by q lambda, total root 8 phi cube r squared, 8 phi cube this one, 8 phi cube r squared m epsilon naught q lambda. This one is the answer. The first one is the answer. So now I am going to show you how to get this equation. I said it should be in your by heart, you have to write it, but here I will show you how to get it using Gauss's theorem. So let us see how that equation is derived. So this is the wire. On the wire I have drawn charged particles, positively charged particles. So the flux distributes like this. So we consider only 1 meter the length, 1 meter length piece, even though the wire is very long. Since these charges are positive, you know from a positive charge how flux distribute away from the charge, like this. Flux force lines, the direction of force lines are away from the charge. So we have to now draw a Gaussian surface around this conductor, around this wire. So I draw a cylindrical shape Gaussian surface because we should be able to calculate the surface area. Therefore we should use some shape of surface of which we could be able to find out the area, surface area. So we draw therefore a cylinder. Color changed. This cylinder is the Gaussian surface, closed one. We should draw a closed one, we should use a closed one. So the surface is this. Think about a cylinder. You can think a tin container, just like this, the surface. So the force lines penetrate through this surface like this. So we have to find out the field strength of this surface. We take a center point here on the surface. So suppose the vector is E, field intensity. Field intensity, that is the force per unit charge. Field intensity is what? Force per unit charge. So to find out it, we can use Gauss theorem. So these red color lines are called flux to all direction. The flux spreads, scatters like this. From top we can see, but on this plane line, plane surface, we draw only these arrows. So Gauss's theorem is total flux, this total flux equals Q divided by epsilon naught, permittivity of vacuum. Epsilon naught is, this Q is the total charge inside the Gaussian surface. Inside, we don't take any charges if there are outside, we don't take them, only we take the charges inside the Gaussian surface. So then there is another quantity called flux density. Flux density is flux divided by area. So to get flux density, we have to divide this equation by area. So there are three equations. This one is 1 flux. What is flux? Then this one is second one, flux density. Third one, field strength equals anytime flux density of the same place. This is the third equation. So using this third equation, using these three equations, we can find out field intensity. So let's do it now. Since E equals B, we need E. So instead of E, we can use B. That is the idea of this third equation. So instead of E, we can use B. B is this one, phi divided by A. So we can write it like this, phi divided by A, because E equals B, B equals this one. So this one must equal to E directly. Then what is this flux? Flux is given by Gauss's theorem. It is equal to Q over epsilon naught. Then we can write E equals Q over epsilon naught divided by A. So we get Q divided by epsilon naught A. Field intensity equals to that one. Then the problem is, what is A? A is the area of the Gaussian surface. So we have to find out the area of this Gaussian surface. So I will draw it again. The Gaussian surface is like this, a cylinder whose radius is r. So what is the surface? If the radius is r, this height is 1 meter. So what is the area? Area is this length 2 phi r multiplied by this length 1. Suppose this cylinder is cut from somewhere and unfolded, so we get a rectangle plate like this, whose this side is equal to phi r, equal to 2 phi r, this side equals to 1 meter. So that is so simple. Grade 11 mathematics. So A equals 2 phi r. Then we can substitute it to this equation. So then we get E equals Q divided by E vector epsilon naught, here A, instead of A 2 phi r. So up to now we have come to this level. So what is Q now? So Q is the total charge inside the Gaussian surface. So inside the wire is there inside. So how much charge the wire contain? Wire has lambda amount of charges to 1 meter length. Lambda is charge density. Charge density. Charge density is what? The total charge distributed along 1 meter length of a unit length of a wire. So that is Q here. So we can use that Q because that is the total charge inside this surface. So we can use lambda instead of this Q. Lambda divided by 2 pi epsilon naught r. So finally field intensity is lambda divided by 2 pi epsilon naught r. This is the equation we should keep in our mind because we can't derive it every time. So that is what I promised you to show how to derive it, that is Gauss theory. If you know Gauss theory well, you can derive it, but in the examination you will not have enough time. So therefore this equation should you should know by heart. This one you should know by heart, then directly you could have substituted it to these equations we used. So this one directly we applied to this one. So thank you very much. I think you understood. We will soon meet again tomorrow. So long. If you haven't still subscribed my channel, please subscribe it.